All right. So, hi guys, how are you doing? So, welcome to this. First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where every concept of physics, chemistry, and maths are being taught to you completely in English. So, this is a series that I host for class 12 students who are looking to revise their concepts of class 11th just ahead of their JEE examinations, mains examinations. So, the topic that we will be covering today is fluid mechanics, and so we'll be going over the key concepts, and then we will also be discussing some questions and getting some practice of the concepts. Okay. So before we get started, let me introduce myself for those of you who might not know me yet. My name is Rohit Dixit and I study mechanical engineering from IIT JEE. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. Now, I also qualified the NTSC Stage 2 as a student and I was in the top 1% in NACP. Now, in all this teaching so far of 8 years almost has been in offline setups. Offline, I've been associated with some of the topmost institutes that you might have heard of in the JEE coaching industry, and I've already coached many students to top ranks in the IIT JEE examinations, and coached and mentored many students and helped them reach their dream colleges. So now I'm starting and trying this bit online here with you guys. So how can you make sure that your studies are going uninterrupted in this lockdown and you are not lagging behind the competition? In fact, you are jumping ahead of that competition of your peers. So you can get yourselves the Unacademy subscription for that. This subscription will give you benefits like live classes where you get to interact with your educators. Now you also have live polls and leaderboards in these classrooms, which keep them highly interactive and fun. And then you have test series and analysis sessions again, which will help you stay on your toes, make you realize where you're lagging behind, where you need to focus more, and how you are doing with respect to your peers. All right, and then of course you have live doubt clearing sessions. So this is a great feature by Unacademy. Like for every Unacademy Plus course, after every three teaching sessions, a fourth session has to compulsorily be a live doubt clearing session. So in that session, you can ask away all your doubts whether it be related to theory or it may be related to problem solving. So your doubts never pile up with these benefits. Okay. Now, apart from that, now Unacademy is also providing you a huge opportunity, which is now you get the chance to study from the best educators all across India from the comfort and safety of your home. All right. So what are you waiting for? Let's go and get this subscription done. So first step would be to install the Unacademy app. Now, once you do that, you will realize a lot of people are not aware of this. But the moment you install the Unacademy app, there are a lot of free courses and free material, free classes that are available on Unacademy. So you can start experiencing those right away. So the moment you install it without taking any subscription, you have access to free courses and special classes. Okay, so these are completely free. And of course, the quizzes that you have. So the kind of quizzes that we have here every Tuesday almost. So all those things you can avail absolutely free of cost. Okay, so get yourselves this app. And to unlock these features, you can use my code RD Live. Okay, so that will help you unlock these free features also. Now, if you see what you if you like what you see and if you like the experience that you get in the free courses and the free classes, so they'll give you a taste of what you can expect from the plus subscription and what kind of study you think you will have when you enroll in plus courses. So if you like that, then if you want to get yourself the plus subscription, then this is how you do it. So you can go to the plus section of the app, select your goal as IIT and click on that get subscription button. As simple as that. Once you do that, you'll be redirected to the payment page where you can use this code RD Live. Again, maximum discount using this code you will get. Okay. So trust me. It is like I don't know how many of you have you heard of the Carnot theorem, by the way? Hmm. I don't know how many of you have heard the Carnot theorem. Carnot theorem says that the efficiency of a Carnot engine is maximum, by the way. So same is the case with that code. So the discount with that code is maximum. Okay. All right. So I won't get into the details of the Carnot theorem. In case you know the Carnot theorem, you also know something else about the Carnot theorem. That it doesn't tell you everything, right? So anyhow, you can use this code RD Live to get your subscriptions. Now you can opt for two kinds of subscriptions. Or you can either go for a plus subscription or you can go for an iconic subscription. The plus subscription you guys know about. That is the most common subscription that people are opting. So this will unlock all the features of Unacademy Plus. You can enroll in the various courses available on the Unacademy and go and study from any of your favorite teachers. Now, The iconic subscription is something different. We'll talk about that in a bit. Let me just tell you, when you click on proceed to pay, now you also get a lot of no cost EMI options to make these payments. So these payments, trust me, are already very competitively priced. Any offline setup, any reputed offline setup would charge you at least 4 times to even 8 times or maybe even 10 times this fees. Okay, that is what you pay in offline setups. Now you're getting the chance to study from those same top educators all across India from the comfort and safety of your home, right? So at these prices, which are very, very competitive compared to what you guys would have paid in your offline setups. So go for this, get your subscriptions as soon as possible, and there is no need to waste any time. The earlier you start, the better it will be for you guys. Okay. So again, let me just tell you about the iconic subscription next. So as I said, I'll be telling you about what is so different about the iconic subscription. So the iconic subscription will take your IIT JEE preparation to the next level. Why and how? So you'll be assigned personal coaches here with your iconic subscription, and you'll be a part of a lot of IIT JEE workshops, okay, which you can attend from time to time. And then you have expert guidelines from time to time. You get a study planner and you get a test analysis sessions. Trust me, if you like more individual attention, then you can go for iconic subscription. This will definitely benefit you more than the plus subscription. It have all the benefits of the plus subscription plus some extra benefits like getting yourself some personal coaches and stuff. Okay, so again, you can go for this if you like that kind of guidance. Now, here is another chance for yourself to win this subscription, by the way. So you can, hello Rajesh, how are you? Hi ARJ, hello Tanya. Hi Ethan, so I have a question. May I, I am really confused. Can I ask? Sure. Go ahead, Ethan. Of course. Hi Motilal, how are you? All right, so let me just, so go ahead, Ethan. Let me answer your question then. Okay. So again, till the time Ethan asks you a question, let me tell you about the Unacademy Combat. You guys should know that this is the most competitive gamified IIT JEE battle. So you can take part in this, and so this will be a good practice for you. You can compete with your peers, see where you stand, and if you do well, you stand a chance to win yourself some really cool prizes. So that is a huge attraction. Not only are you testing your knowledge, testing it in comparison to your peers, but you're also getting awarded for performing well right away. Okay, so the next event is going to be on 20th of December. So the prizes would include a lot of amazing prizes plus the Unacademy subscriptions. So they are being given away. All right, so make sure you enroll now in this and use the code RD Live. RD Live, trust me, is a lucky code. If you use this code, you are bound to do well. Okay, so moving forward. Now, Unacademy is also holding a boot camp for class 10 students who are looking to prepare for IIT JEE 2023. So any class 10 students can join this. This boot camp will be hosted from the 13th of December to the 19th of December. So you will get a taste of what it's like to prepare for the JEE. You know how your next 2 years are going to be. All right, so you can take part in this. See, and those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app. So yes, I know I'm telling you guys a lot of work to do, right? So you'll be saying, okay, sir first says get this subscription, install the app, now go to this, go to that. Yes, but that's all going to benefit you. So when you join us on the Telegram app using this link, what will happen is that you will get timely notifications of all the sessions and lessons happening here, so that you're not missing out on any of those. Okay. So trust me, a lot of people who have subscribed to the channel often complain that, sir, we are not getting timely notifications. So if you have that kind of problem, so there is a backup. It's always better to be safer, have more options open for yourself. So be a part of this Telegram group, receiving timely notifications, and make sure you're not missing out on any lectures. All right. So what does Ethan has to say? So Ethan says, sir, my college is starting the pre-board next week, and I have two choices in front of me. Either I can copy chemistry tomorrow and learn physics Wednesday, okay, or to do the opposite. But the problem is, Okay, so Ethan's dilemma is huge. Okay, so I'll give Ethan some more time to express his dilemma, and then maybe I will get to helping him. So this is quick review for fluid mechanics is part one. But if you remember, if you joined the session yesterday, there was some part of gravitation that we had to leave out. Right, we did not have the time to cover that. So we'll go over that first. So this was the topic that was left for yesterday from gravitation, satellite motion. So we'll be talking quickly about satellite motion, and then we'll move ahead and start our discussion about fluid dynamics. So Ethan says chemistry I know somewhat, but I bunked physics and now I don't know anything in physics. Okay. Even if I start now, by the time I'll cover, I'll only be able to do it board level. So okay, Ethan, let's get some priorities right. Okay, so trust me, board is definitely very important because boards you are getting only one chance. JEE mains, you will be getting four chances, right? JEE advance also, you can take another drop if you don't do that well. If you think that this time you ended up wasting a lot of time and you did not leave yourself enough time. So I think you should first focus on the boards. Trust me, that's the first step. You want a decent percentage in boards. Trust me, that percentage is going to be a part of your resume for all your life. My class 12 percentage is still there on my resume, and since I did well there, so trust me, it's always going to be an add-on in your resume. It will always help you in wherever you are in life. Okay, so trust me, those things always count. So let's make the priority your boards first. Okay, that should be the first step. If you have prepared your NCRT well enough, trust me, half the at least half the mains is already covered. Okay, you will be able to score at least 50% in mains, so that will help you with your mains also. So which one should I do, chemistry or physics? Because it'll be easy for me to get back on track for chemistry but not physics. So of course then you've answered yourself, right? You have already answered yourself. I don't think I need to say anything more, right, Ethan? So if you realize that chemistry you can still manage, but physics is the one where you need to pay more attention, then do that. Do that. So everybody knows their own strengths and weaknesses, right? So trust me, when I was a student, I was very weak at maths. So I used to give extra time to maths, and trust me, chemistry and physics I always managed. So I think what I would like to advise you, Ethan, is go and work on your weakness. Make sure that that is no more your weakness. See, the only way of eliminating your weaknesses or doing well is that eliminate your weaknesses, right? So that is what I would like to tell you, that okay, if you think you can manage chemistry later also, then do it. Also, I am state board, so 100% of my paper is NCRT. So even if I do physics up to board level, will it help me for JEE Mains? Absolutely. Absolutely, Ethan. Yes. I understand. I understand. It's okay. It's okay. I know. I am going off the topic for like 2-3 minutes, but I think it's really important to help someone in need. Okay. So I understand you, and I can feel your confusion. That's all right. So yes, absolutely, Ethan. I would tell you to focus on your boards, and if you do your NCRT, then trust me, you are pretty much sorted for your mains also. Up to 50%, you should be able to perform in your boards. Okay. So I hope that helps you. All right. Now let's get started with our discussion on satellite motion. So I'm only going to quickly go over the formulae. Okay, important formulae. We are not going over the derivation. So if you have an orbit, if you have a satellite which is rotating in some radius r with a velocity v naught, then the orbital velocity v naught and the radius of the orbit can be related using this expression. So again, must remember, very important. So if you do not remember this, then hurry up and memorize this. Okay, this is a very frequently used expression. Now, if r is close to capital R, so that is if your satellite is in a very low orbit, so near Earth orbit, that is called. So this is called a near Earth orbit. So in a near Earth orbit, the velocity of the satellite or the speed of the satellite should be root gr. Okay, so that's another result that you can maybe memorize, maybe not memorize. That's all right. That's all right. If you remember the previous one, then this is nothing new. Okay, right. So let's move forward then. Next, the time period of the motion of the satellite can be easily calculated. How? Okay, so okay, all right. So here we go. So the period of revolution of any satellite can be calculated as the distance covered, that will be 2 pi r over the speed, right? So when you do that, this is the expression that you're getting. Again, this is very, very important. And from the above equation, you can also see that t square is in fact directly proportional to r cube. So your Kepler's equation also is proven from here. So remember that this is important. Often a lot of questions are asked from this, okay? Now, geostationary satellites, they are special kind of satellites which appear stationary with respect to Earth. And how will they appear stationary with respect to Earth? If they are rotating with the same omega as that of Earth. So the time period of revolution of a stationary satellite, of a geostationary satellite, in fact, would be 24 hours. From here, you can even calculate the radius of the orbit of a geostationary satellite, okay? So geostationary satellites are used a lot in your communication. All your communication satellites are usually geostationary satellites so that you have yourself a good alignment. So, hi Sita, how are you? Next, when concerned with satellite motion, the energy of a satellite, potential energy would be given like this. So, if r, small r, is the orbit radius of the satellite from the center of the Earth again. So, obviously, you know the potential energy is this. The kinetic energy obviously would be half m v naught square. Now, we calculated the value of v naught in terms of r. So, when you calculate this, this turns out to be half the magnitude of the potential energy. After how much time you start fluids? So like in 5 minutes. Okay, so I had like 5 minutes of discussion left for gravitation and motion of satellites. So just give me 5 more minutes and trust me, this is also a revision. This will not harm you, right? The total mechanical energy of a satellite comes out to be negative. The negative energy suggests that it is bound to the gravitational field. The binding energy obviously is positive magnitude, or the magnitude of the total binding energy or total energy. If you give that much of positive energy, that is a satellite can escape the gravitational field of Earth, right? Now let's quickly go over a question that was asked in JEE Mains 2016 with regards to satellite motion. So this says a satellite is revolving in a circular orbit near the surface of the Earth. The minimum increase in the orbital speed which is required so that it can escape from the gravity of Earth is, okay. Why don't you guys give it a go? Let's see. Let's see. What do you think will be the answer? So imagine the satellite is orbiting in a near Earth orbit, right? So think about this. Think about this. So what will be the minimum increase in the orbital speed, by the way? So pay attention to the language and try and answer this. Okay. Let's see if we can figure this out. So after this, I have one more question. I think yeah, two more questions. Okay. And then we start with fluids. Okay, Sita. Just a couple of practice questions. That's it. That will also help you, right? Why don't you try and give me an answer? Let's see. What will be the increase? Please notice the word increase in its orbital speed. Okay. Let's see if you guys can figure this out. Anybody? Any answers? So you should immediately realize it cannot be this. This is the escape velocity. So this option obviously cannot be correct, right? How about the other options? Okay. Think about this. Think about this. And let's hurry up. Hurry up and let's try and get an answer quickly. Come on, guys. The faster you answer, the faster we can move on to the fluid dynamic part. Let's see. No answers yet, which is strange. Okay, as Pandey says, A is correct. Let's see. Let's see if A is in fact correct. All right, all right. So let's just quickly move ahead. So in a near Earth orbit, for near Earth orbit, would you know your velocity? We already discussed would be root gr, correct? So we talked about this. I hope you remember. For a near Earth orbit, the orbital velocity is root gr, correct? Now you've been asked to find the increment in the speed. Okay. So you also know the binding energy. Binding energy would be half, and that was gm over r, correct? Which was the magnitude of the total mechanical energy, correct? So I know, it already has, it needs this much energy, right? So it needs this much energy. So I can say half v final minus v final square minus half m v initial square. This should be equal to half g m, which is mass of Earth, mass of satellite over r, correct? Okay. So let's see what that gives us. This and this will get cancelled, and I can get v final square is nothing but vi square, which is gr, and at times I can write this as also plus gr. So v final should be root 2 gr, right? So what is the change in velocity? Therefore delta v would in fact be this option B, guys. The answer is option B. Okay, delta v would be root 2 gr minus, right? All right, so it's option B. Oh, no, not A, not A. All right, let's quickly talk about this next problem, which was asked in JEE Mains 2013. Okay, you have to find out the minimum energy required to launch a satellite from the surface of a planet of mass m and radius r into a circular orbit of an altitude. Please always pay attention to your language. So, what is the energy required to launch a satellite of mass m from the surface of a planet of mass capital M and a radius r into a circular orbit of altitude of 2r? Let's hurry up with this one now. Any ideas? This and one more, and then we'll move to fluid dynamics. Okay. So hurry up about this. Let's try and answer this very quick. So I think by 4:30 we can start with fluid dynamics, right? Okay. That is so strange. Why are you guys not trying? See some more tries, guys. Again, trust me, theory revision is as important as your practice. So try and find the answer and give me an answer. Quick, come on. Okay. So yes, AP, I know. You guys may feel that I'm pressurizing you guys at times. But trust me, you should get used to that pressure, right? In your JEE exams, you will feel a lot of pressure. Trust me. So that's all right. I'm only trying to push you a little for your betterment. Okay. All right. All right. So why don't I just discuss the answer? So I know what is the energy at the surface. Energy at the surface would be half, in fact, minus gm over r. Right? That will be the energy at the surface. Now you want to find the minimum energy required to launch this into an altitude of 2r. If it's in the altitude of 2r, so energy at in the orbit, that would have been minus 1 by 2 gmm over the radius of the orbit would have been 3r. So energy required would simply be the difference of these two. So that will be gmm over r times 1 minus 1 by 6. That is 5 by 6 gmm over r. Right. So that is in fact option D. So well done, you guys. Option D is the correct answer. All right, very well done. I think three of you gave the right answer. So very nice. Now this is the last question that we have for satellite motion, and then we will start with the fluid discussion. Okay. So you've been told a satellite of mass m revolves around the Earth of a radius r at a height x from its surface. Okay, so x is the height from the surface. Please note, again, pay attention. Always learn to pay attention to your language. Now, if g is the gravitational acceleration due to gravity at the surface of the Earth, the orbital speed of the satellite is. Again, this should be simple. Come on. I hope you remember the formula for the orbital speed, right? What was the formula for orbital speed? Hmm. So let's hurry up, answer this very quick, and let's move on to our discussion of with fluids. So you'll find the orbital speed of the satellite. Again, remember your formula. If you remember your formula, trust me, half the JEE is done. Okay, so AP says it's D. Let's check it out. So for those of you who don't remember the formula, let me just tell you. Orbital speed was root of Gm over R. Right? So the formula for orbital speed. Now you've been told that the orbital speed is orbital radius would be r plus x because the height above the surface is x. So can I say in this case the orbital speed is nothing but root of gm over r plus x. Right now, all I need to do is multiply and divide both the sides, numerator and the denominator, by r square. If I do that, you will notice that this term is nothing but g. Correct? This is g. So what you're getting your answer as is P naught equals root of gr square over r plus a. So yes, absolutely correct. All you guys, D is the correct option. Well done. All right. So I think so. You guys have gotten a hang of how to analyze problems of satellite motion, especially for mains level. Okay, that is the aim right now. Now let's get started with our discussion over fluids, and we'll be starting with our discussion of fluid statics. Okay, so what is fluid statics? It's the behavior of fluids when they are at rest. Okay, moving fluids will behave slightly differently, so that is why we divide the study of fluids into two categories: fluid statics and fluid dynamics. Both of them combined is called fluid mechanics. Okay, so first let's talk about the introduction. So, what do you understand by a fluid? What is a fluid? What's the definition of fluid? Now, technical definition of fluid is this. A fluid is a substance that deforms continuously under the application of a shear or tangential stress, no matter how small. Okay, Sita, hi. So most welcome. I hope you find these classes useful. Okay, and I hope I can help you guys with your revision. Okay, so that is the definition of a fluid. A fluid is a substance that deforms continuously under the application of shear stress, no matter how small it is. So even if you apply a negligible shear stress, this kind of substance continuously gets deformed. So I hope you guys know what shear stress is. Shear stress is something which will distort the shape of an object, right? So if I can maybe show you an example. So yeah, so if I have a book, let's say, so let's get out my favorite book. So this book is General Problems in Physics by I.E. Erudov, right? So what is the shear stress now? So you can apply different kinds of stresses, right? This is tensile stress. The shear stress is something like this, which you apply at the surfaces like this, tangential to the surface, right? So such a stress would try and distort the shape of an object. Now, if I apply a shear stress here, you realize that after getting distorted a bit, there is no more deformation until unless I increase the stress, right? For a particular stress, you only have a certain deformation, and then the body stops deforming. So, hello, Somed. All right, thank you so much. Now, the property of fluids is that they cannot withstand even a negligible shear stress, and that is the reason why they don't have fixed shapes and sizes. Okay, as a result, fluids have no fixed shapes. Okay, and in our study, now we will be focused only on ideal fluids. Okay, especially okay, so yeah, the net fluctuates a bit. Okay, Sita, so that may happen sometimes. The internet is slightly fluctuating. Hmm, I know, but trust me, it gets stabilized then. does get stabilized. Give it some time. So as I said, because of this property, the fluids do not have any fixed shapes, and we will focus only on ideal liquids. When we are talking about liquids, that is, so what is an ideal liquid? An ideal liquid is something which is incompressible and non-viscous in nature. Incompressible means its density can never change. Okay, so its density can never change, and it's non-viscous, so there is no frictional force between two layers of a fluid. So that's the only kind of liquid that we will consider while we are doing our study. Okay, so again, the study of fluids can be divided into two parts: fluid statics and fluid dynamics. Statics refers to fluids study of fluids at rest, and dynamics refers to study of fluids in motion. All right, so now we will discuss the characteristics of a fluid. So when you want to study a fluid, you need to study some basic characteristics, right? Yeah, so that happens. That happens, Rajesh. Okay, so what happens is that the neck keeps fluctuating a bit. So that is why sometimes you may see a little lag, and other times it will become smooth. So nothing much I can do about that. Okay, trust me, I've got a wonderful net speed at my place. It's just the software, streaming software, that has some glitches, I guess. Now, so first characteristic that we can characterize a fluid by is density. So density, by definition, is mass per unit volume. Now, we will consider only incompressible fluids. So for all incompressible fluids, the density is supposed to be constant. Now, the density of a liquid sometimes is also expressed as its the ratio with the density of water at 4 degrees Celsius. Now, this is called the relative density. So whenever you told the density of any fluid, there are usually two ways of expressing the density. Either you'll be told the absolute density, or you'll be told the relative density. So what is relative density? Relative density is nothing but the ratio of the density of a material with the density of water at 4 degrees Celsius. Okay, that is also known as specific gravity. Okay, so relative density can be specified with respect to any other fluid. When it is specified with respect to water, then this is called specific gravity. Okay, so you should just be familiar with all the terms. Okay, specific gravity of a liquid is the density of the substance over the density of water at 4 degrees Celsius. Okay, next, how does the density vary with temperature? So you guys will know that whenever you apply heat, so anything expands, right? So the density variation with respect to pressure can be given as this. So as the temperature of a liquid is increased, the mass remains constant, but the volume increases, right? Due to intermolecular separation being increased between the two. Now, the density of a liquid hence decreases with increase in temperature, and this is the formula that you have. Okay, where gamma is the thermal coefficient of volume expansion. Okay, again, if you don't know this, then you should have studied this in thermodynamics. And if you don't know what this is right now, you can watch the review of thermodynamics when I take it, and then you'll get to know about this. So, in case somebody asks you how does the density vary, this is the formula that you want to use. Okay. Next, how about the variation of density with respect to external pressure? So if you increase the pressure on any of the liquid, the density, if the liquid was not incompressible, then the density would have increased, right? So it turns out the change in density is related to change in pressure like this. Okay. This is the expression that you want to use. That delta rho, which is the change in density, is equal to rho times change in pressure over B, where B is the bulk modulus. This is the bulk modulus. Again, I hope everybody knows what bulk modulus is. So if you don't, then you can wait when we recap solids and all these stresses and strains, right? So this is the bulk modulus of elasticity. Now, please note, for ideal liquids, the bulk modulus can be considered to be infinite. Okay. So for ideal fluids, you can consider that their bulk modulus is actually infinite, right? So if it becomes infinite, then you realize for any change in pressure, the change in density would be zero. Okay. So that is what we are going to be looking at. The next very important characteristic of a fluid with which you study a fluid is pressure, of course. What is pressure? Whenever a fluid is at rest, even when it is in motion, by the way. So right now we are focusing only at rest, okay, fluids at rest. So we will realize that any fluid exerts a pressure perpendicular to the surface of contact with it. So if you put any surface in contact with the fluid, then every fluid exerts a pressure perpendicular to that surface. Okay, it exerts a force. Now, this perpendicular force per unit area is called the pressure applied by the fluid. Okay, so its definition is pretty clear. And why does this happen? So imagine if you had this liquid, right? Imagine there is a liquid, and you put a surface inside this. So I inserted a surface inside this like this. So what is happening is that in all liquids and gases, those molecules that constitute your liquids and gases, they are constantly in motion. Okay, so you guys would be aware of this. All the molecules are constantly moving here and there with random velocities, thermal agitation, right? So these randomly moving molecules will go and strike any surface that is kept near them. So this collision results in the force being exerted on the surface of any fluid, which is of any surface that comes in contact with the fluid. Okay, and pressure is defined as the perpendicular force. The force exerted would be perpendicular. I hope you realize in any kind of collision. So if you have a collision like this, so the force is always exerted in this direction, normal to the surface, right? So this force per unit surface area is called the pressure exerted by. Okay. Now let's talk a little bit more about the pressure. So fluid pressure acts perpendicularly to at any surface. So I've already told you why is this happening. This is because the pressure results from various collisions of molecules happening continuously at the surface of the any surface that is in contact, right? And any collision results in a normal force being exerted. So that normal force will be always perpendicular to the surface, right? Now, no matter how the surface is oriented, it does not matter whether you keep your surface like this or you orient your surface like this, okay, or you oriented your surface like this. Doesn't matter. As long as you keep it in a liquid, as long as you keep it in a liquid, whenever you say, talk about the force that any one surface is feeling, it will always be perpendicular. So this surface will feel a force in this direction, this surface will feel a force in this direction, this surface will feel a force in this direction. So the force of this liquid pressure is always perpendicular to the surface of the solid, to the area or the orientation of the surface. So it is always along the area vector, irrespective of the orientation. Okay, so please remember that. Now, hence, pressure has no intrinsic direction of its own. Pressure has no intrinsic direction of its own. It's a scalar. By contrast, force is a vector and has a different direction. Wherever pressure has no direction. So, if you had a surface like this, the pressure would act like this. If you tilted the surface, the pressure starts acting like this. So, it doesn't matter where you tilt this. So, that is why we can say that pressure inherently has no direction of its own, and that is why we treat it as a scalar quantity. Okay. Now, when you are specifying the pressure of a liquid, then there are two ways to usually do that. Now, you can either mention the absolute pressure, or sometimes what we do is we use another term which is called gauge pressure. What is gauge pressure? The excess pressure above the atmospheric pressure is usually called the gauge pressure. Okay. Now, the total pressure or the absolute pressure can be related with the gauge pressure with the help of this equation. Okay. So gauge pressure at any time would be equal to the absolute pressure, which is the total pressure exerted by the liquid minus the atmospheric pressure. The difference is called the gauge pressure. Now you will notice that pressure is always positive. So let's make a quick note of that. Pressure is always positive, or let's say absolute pressure. Just to be clear, absolute pressure is is always positive. It can never be negative. Cannot have uh, for a collision, you will only feel a push. You cannot feel a pull due to a collision, right? The absolute pressure is always positive. How about gauge pressure? Positive. However, your gauge pressure can be negative. So please remember that if anywhere you have been given a negative pressure, then has to be the gauge pressure. It cannot be the absolute pressure, correct? Any example of gauge pressure? Absolutely, why not? So let's say if I have, let's say, this as open, right? So this currently has atmospheric pressure inside it. Now, if I close the lid and if I suck half the air out, if I suck half the air out, what would be the pressure inside this? The pressure inside this would have been half the atmospheric pressure. So what is the gauge pressure of the gas inside? The gauge pressure of the gas inside would be minus times half the pressure of atmosphere. Okay, I hope you followed that. So, however, gauge pressure can be negative. Now, other ways also are there of telling about the gauge pressure. So let's talk about this. So if this is a substance that is kept at the bottom of the a container, okay, yeah, like a piston, exactly. So imagine you had a surface, the surface which is kept at the bottom of a liquid, right? And there is a liquid here. There is a liquid here. So you realize the pressure at the bottom at this surface. We will talk about this. If this is the height, then the pressure here P is P atmosphere plus rho GH, right? Correct. Now here rho GH is called the gauge pressure. This term is called the gauge pressure. Okay. Now I hope that makes it even more clear. Okay. Right, Sita? Okay. So if there are no confusions, should we move forward? This rho GH would be called the gauge pressure. This is the excess pressure. This is the pressure in excess of the atmospheric pressure. Okay. All right. Great. Next, let's talk about the variation of pressure in a stationary vessel first. So, how does the pressure vary in a stationary vessel? The pressure at all points at the same horizontal level is always equal. So, if this fluid was stationary, then please note this is a very important consequence. Pressure at all points at the same horizontal level is always equal. A very important point that we use in a lot of problem solving, right? If you take a one horizontal level and you take any point here, so you take like say 3 points here, all of them would have the same pressure. Again, I'm not going to explain that. We are only quickly revising the key concepts. When I take up this topic for class 11 students, that is for 2021 aspirants, then we will have a detailed discussion. I'll give you proofs of all this. I will prove this, but later for when I take this up for class 11 students. Right now, we are only revising, so I'm just quickly highlighting the key ideas. Now, at a depth h from the free surface, okay, so from the free surface of the liquid, the pressure can be given as P naught plus rho GH, where P naught is the external pressure. Okay, P naught is the external pressure. So this is the external pressure. Usually we will P naught would be equal to the atmospheric pressure because you will have the container open to the atmosphere. Sometimes you may have this kind of a situation, right, where you have a piston and you may have pressed the piston a bit. So you may have had this kind of a situation also where the P naught would be greater than P atmosphere. That can also happen. P naught can be less than atmospheric pressure also, right? You can close the container with the piston, increase the pressure or decrease the pressure, by the way. So the pressure can be manipulated. Okay, external pressure can be manipulated. So uh, saying this is not always right. Okay, this is only correct if your container was open to the atmosphere. Okay, so as you have here, right? This formula is true only if no external force is acting on the liquid except for the force of gravity again. You also do not apply any external force on the liquid, only the force of gravity is acting. So because of the force of gravity, you will see that the pressure increases in the direction of the gravity, right? So that is what happens. So the gravity acts downwards. So if you move in the direction of the gravitational force, which is the only force that the liquid molecules are feeling, you will realize that the pressure will increase. Again, you can prove that, but again, we are not talking about the proofs here. Okay, I will show the proof. In case you are interested to see the proof, then you can watch my lectures on fluid and, when I take them up for class 11 students. Okay. Next, how about the variation of pressure in an accelerated vessel? Okay. So suppose what happens is that you are accelerating this vessel. Okay. So if this vessel was accelerating with some a vector. So when I go into the reference frame of the vessel, please note that we are talking about fluid statics. So we are only going to analyze the vessel in a reference frame where it is stationary, right? So if it this entire vessel was being accelerated with some acceleration of a vector, when I moved into the reference frame of the vessel, you will realize that every molecule would feel a pseudo force. The molecule which has a mass of small m would be feeling a force m times a vector with minus sign, and then it would be feeling m times g downward. So I can say that the effective value of G would be a vector sum of the G vector. So I can write this as G vector and the minus A vector. Okay. Now you will also notice what will happen, that in the reference frame of the container, the reference frame of the container, the net force, the net force experienced by any molecule, the net force experienced by any liquid molecule becomes, it will become uh, m times G vector minus A vector. So I can write this as equal to m times G effective. So it just feels that the effective value of gravitation, acceleration due to gravity has changed. Okay. So G effective, obviously G effective would be, G effective vector can be found as the vector sum of G vector and minus A vector, where A vector is the representing the acceleration of the fluid. Okay. So if I add both these vectors, let's say if I add both these vectors, the vector sum would come somewhere here. Okay, by triangle or parallelogram law, I can see that this is going to be the direction of G effective. So the pressure would now increase in the direction of G effective. Please note that pressure variation happens in the direction of G effective. Pressure now varies in the direction of G effective. That is again going to be a huge thing. Now, in this case, you realize that all points which are at the same horizontal level will not have the same pressure. In fact, all points which are perpendicular to the direction of G effective will now have the same pressure. So that is something very interesting that you will realize, that in such a case, what will happen is, so let's take a brighter thing. So if you have these lines which are perpendicular to the direction of G effective, at all these points the pressure would be same, and the pressure here would increase. And if you're moving by a distance, let's say d, then the pressure change delta p would be equal to m times d times G effective. Please note, the moment you accelerate a vessel, this is what starts happening. For with respect to the vessel, the effective value of G has changed, and now the pressure varies in the direction of the effective G. And perpendicular to the direction of effective G, there will be no variation of pressure. All the pressures would be the same. And another result would be that this surface would get tilted. Okay. Now we'll talk about that also. So first we'll talk about. I hope you guys should know now how the pressure variations can be calculated. Okay, any pressure would change in the direction of G. Now you can also break this into a lot of components. By the way, you can have G effective. You can write G effective as, let's say, some a Gx I cap plus a Gy j cap plus a Gz k cap. Let's say this is the general form, right? In general, I can resolve this effective G into three directions. Okay, the resultant of A vector and G vector can have possibly three components, right? In X, Y, and Z. Now you will realize that when you were moving in the direction of the force of gravitation, the pressure was increasing by whatever the distance you are moving. Okay, so with respect to the distance, right? So here, if you move in X direction, since the X component of gravity is Gx, so when you move in the X direction, you will realize delta P in X direction would be given as m times rho times the rho, because the variation of pressure is given by rho gh. My bad. So it will be given as rho times delta x times gx. So if you move in x direction, the pressure will vary like this. Similarly, if you move in a y direction, the pressure variation can be given like this. So as in vectors, you can individually analyze the directions. Similarly, you could have found the variation in pressure if you moved in the z direction. Okay, so remember that in individual directions also, all you need to do is find the components of G effective, and you can find the variation of pressure due to these components. Okay. So y component of the gravity, I hope you realize in the last example only, creates only variation of pressure in the y direction. When there was no acceleration, I saw the pressure varies only in when I move in the y direction. There is no variation of pressure in the x or in z. Okay. If you had components of G, however, in the x direction and the z direction, now the pressure would vary in the x and z direction also. Okay. Now, next we'll talk about what just happened. Next, let's talk about the characteristics of the shape of the free surface. How will the shape of the free surface behave in an accelerated vessel? So it turns out the shape of free vessel of free surface of the fluid. Now let's compare these two situations. So in one, I'm not accelerating the fluid. So in one, you imagine that a U-tube was there, which had water and it is kept horizontal. And in case B, it is kept like this. And in case C, it is now being moved. Okay, so now it is being moved in this direction, acceleration A. So in these three directions, you would have seen that the liquid surface would always in these two it would be horizontal. Okay, you can see that. Okay, I don't know, I don't have a plastic bottle, but if you take a water bottle and if you tilt the water bottle, you will realize that the face of the surface of the liquid always remains horizontal only, right? So why is that? Think about this, why that is. Since by definition a liquid cannot withstand a tangential stress, its free surface always aligns itself perpendicular to the direction of the net force. Okay, what is happening is let me tell you, here consider the molecules sitting at the surface, है ना? Right, so do that. Consider the molecules sitting at the surface here. Now these guys are feeling a force of mg downward. Now you realize there is no component in this direction. Imagine if this was the shape, if it remained like this. Imagine if the surface actually bent and became like this. So hypothetically, then you would have realized that the molecules on the surface would have felt a force of mg like this. Now this mg would have had two components, right? One component here and one component here. Now this component would have provided a tangential stress or a shear stress, and it would have pulled all the molecules here. Okay, now since this guy cannot withstand a shear stress, the molecules would have started moving, the distortion would have started coming in, and it would have stopped finally till the liquid becomes horizontal, because that is the only direction that the free surface can have so that it does not feel any shear stress. Okay. So similarly, if imagine I am accelerating a vessel. Now imagine I have this vessel and this has some water or any liquid. So let's say this is like this. And now if I accelerated this, so this is an example, I'm accelerating it in this direction, horizontal direction. Now what is the direction of effective G? So you will realize G effective would be nothing vector sum of minus A and G. So this would have been the G effective, like this. Now you would have realized that all the forces on these molecules would have started to act in this direction. This would have had a component like this and it would have had a component like this. Now this component would have started dragging all the molecules from here to here, right? This component of force would have started dragging all the molecules here and here. So you would have seen the water level rise here and go down here. Eventually, what would have happened was that the surface would have bent like this, and the bending would have stopped when the free surface would have aligned itself perpendicular to the direction of this G effective. Okay, so that is the property of free surfaces. They always will align themselves perpendicular to the direction of G effective. Okay, so this is the effective direction of G. Free surface will stop here. It will be bent. You can even see that practically. So you can take a bottle of water next and you can accelerate that. You will see that the water level will rise in one side, and you can even calculate the angle. by which this liquid surface rises, right? So we'll talk about that also. So finding the angle of the free surface. So let's do that. So I have been told that, okay, imagine here was a vessel, and this vessel was being accelerated with some acceleration a this direction. So I will realize that if there was liquid, and let's say finally liquid becomes like this, right? So this is how the liquid has become. And let us also say that this is the angle theta, right? So how can I find the angle theta? So I know that this surface would be perpendicular to the G effective. I can find a G effective. The surface becomes perpendicular to G effective, right? So if I know this angle, or if I know this angle that the G effective makes with the horizontal, okay, so this angle is the angle that G effective makes to the horizontal. That will be 90 minus theta, right? So if I want to calculate that, I will say that what is the angle of G effective? It is nothing but the vector sum of A and G. Correct. So I will draw A and G, and the direction of G effective I can see is somewhere here. This is the direction of G effective, and I will realize in this triangle, if I can find this angle, this will be 90 minus theta. Correct. So this is 90 minus, this is theta. So from this triangle, what can I say? I can say that tan theta is in fact A over G. Right. So realize that tan theta was A over G. That is the angle by which the free surface of the liquid would get tilted. Okay, it would be pretty simple to see. Okay, so there are a lot of ways to derive this, but this is what I like doing. Okay, so if you can find the direction of G effective, you will know that the free surface will align itself perpendicular. So if free surface makes an angle theta, then this is also theta, and that value of that theta would be tan inverse A by G, where A is the horizontal acceleration, by the way. So here we have taken a specific case of horizontal acceleration. It's not necessary. The acceleration could have had any other direction also. So please remember, what you would have done was eventually you would have done that if there was a more complex situation, which usually won't be asked in mains at least, you would have found the net acceleration in x over the net acceleration in y. What you assuming there is no acceleration in z. Okay, assuming az is 0. There is only acceleration in x and y directions. Okay, so that is how you could have gotten your angle made by the free surface. Again, this equation again, I really doubt that mains would ask questions on this. So it's more likely to be asked in advance. Mains will definitely ask you this, so this is important for mains. Okay. Now, why don't we try a practice problem? So this problem says that a certain depth at in an incompressible liquid, the absolute pressure is P. At twice the depth, what will the absolute pressure be? At twice the depth, what will the absolute pressure be? Option A, less than equal to P. Option B says equal to 2P. Option C says less than 2P. And option D says greater than 2P. So if you have been paying attention, let's see. Let's see how do you feel about this. So we are starting with a basic conceptual problem, okay? Let's see how much attention you guys have been paying. So can I have some answers then? Okay. Let's see. Come on, people. Come on. Give me some answers. So yeah. The problem is today I have got an opaque kind of a cup and an opaque kind of a jug for water. So I can't show you those angles that liquids would have made. Okay, so AP says C. Okay, how about others? So theta says D. Hmm. Anyone else? Anyone else wants to give it an answer? Okay. So C is correct, by the way. You need to pay a little bit more attention. Okay. C is in fact correct. See how. Follow this. So imagine at a depth. Imagine there is a body of water. Now at a depth of D. At a depth of D, the absolute pressure has been told to you as P. So if the external pressure was P naught at a depth D, what will be the absolute pressure? Can I say that P would be equal to P naught plus rho G T? Correct. Now, how about at a depth of 2D? So if I move further down by a distance D, and let's say here the pressure is P dash. So can I also say that P dash is P naught plus 2G T, right? Now this is less than 2P, less than 2P. You realize from here what would have been 2P? 2P would have been equal to 2P naught plus 2 rho G. So can I say 2P equals P dash plus P naught? So is it equal to P? No. Is it equal to 2P? No. It is less than 2P. P dash. P dash. You are getting P dash is 2P minus P naught, right? That is the pressure at a depth 2D. So be very careful. Be very careful. So the correct answer is C. Okay, Sita. I hope you realize where you made the mistake. It is not going to be greater than 2P. It is going to be less than 2P. So that's why these small conceptual problems are also important. A lot of time people are not paying attention here. All right. Now let's try another question. Okay, so this is a tricky question. You have been told that a rectangular box containing water is accelerated upwards at 3 meter per second. Okay, so no, I think 10 meter per second square. Okay, so not 3. Figure says 10. So I think it should be 10 only because the units also don't make sense. So it is being accelerated upwards at 10 meter per second square on an inclined plane, making an angle theta or 30 degree to the horizontal. Now the slope of the free liquid surface with the horizontal, that is what you have to find. What is the angle that this liquid is making with respect to the horizontal? Try this. Try this. Hmm. So again, if you remember your formula, how did I tell you? I told you a general formula also, by the way. Remember this. That should help you this out. Okay. Let's see if we can figure this out. Hmm. Come on, people. Let's have some answers. Let's see some answers. So try this. Try this. That's why I'm getting you a tricky situation, not the straightforward situation. Okay, straightforward situation you guys are too used to, right? Tan inverse A by G. So it's like everybody can immediately tell me that the moment I ask that kind of question. That's why I brought a slightly tricky question. Now, please note you have to tell the slope of the free surface with the horizontal. Krina Patel thinks it's C. Okay. Okay. How about others? So AP thinks it's C. Krina Patel also thinks it's C. So is it Krina Patel or Krishna Patel? You miss SH? No, I think yeah, that's I don't know. Okay, how about others? How about Sita? What do you think would be the answer? Hmm. So why is waves so tough? Waves is not at all tough. Not at all tough. What are you saying, Noman? It is one of the simplest and the most scoring topics. Okay, so Noman also says C. Okay, let's see. All right, so I told you you have an acceleration of 30 of 10 directed at 30 here. So you can break this into two components, right? So what will be this component? This component would be 10 cos 30, 10 cos of 30, and this component would have been 10 sine of 30, correct? So, okay. So effective G, when I talk about effective G, then you have G here. So for effective G, you will realize you have one component like this, which is 10 cos 30. 10 cos 30 is 5 root 3. And then here you have 5 and you have 10. So you have 5 like this. So G effective would have been like this. So now you know the direction tan theta, how to calculate that. Tan theta would have been tan 5 root over 5. So yes, theta equals 60 degrees. That is the correct answer. I'm outside. I don't have pen to do that problem. Okay. No issues, no issues. All right, yes, 60 degrees is the correct answer. So well done, all you lot who gave this answer. I think all of you gave the correct answer only. So very well done. So that means you have been paying attention. Great. Now let's try a problem which was asked in JEE 2010. This was in fact asked in advance, I think, if I'm not wrong. So you have a YouTube and that is rotated about one of its limbs with an angular velocity omega. The difference in height, capital H of the liquid levels is. Okay, so that is what you have to find. So when you rotated this with some angular velocity omega, you realize that the liquid will rise in this one and liquid would have dropped in this one. If the difference in the heights in the two limbs is capital H and the base has a length, so what? How can you relate? How can you find H in terms of omega, L, and G? Okay, so so are you trying to give the answer for this one? You trying to give the answer for this one? Let's see. So what do you think about this? Okay, so AP says D. All right. How about others? How about others? What do you think? How can you calculate H? Okay, in questions like this, you will see something. You can see that dimensionally, or not all options are the same, right? Can you figure out dimensionally which are the correct options? Oh, you found problem in rotating container concept. Okay. I will show you how to do this, and I'll also tell you a very uh, cool shortcut for this. Okay, there are a lot of ways of solving this. Don't worry. Okay. So I hope you can realize that dimensionally only these two are correct. If you just look at the dimensions, only these two are correct, right? These two are dimensionally wrong, right? I hope you remember that when you talk about the maximum height in motion under gravity, so that height was v square over 2g, and v is omega r usually. So dimensionally this should have some omega square r square over 2g. So dimensionally the dimension should be omega square some length square over g. So only two options are dimensionally correct, right? तो बिंदास बादशाह कुछ लिख के इन्होंने हटा दिया. Okay. Now let's see which one of these options is correct. So let's draw ourselves that situation. So imagine this is a tube, right? And let's assume that there was liquid in this. Okay, and this was being rotated about this with an angular velocity omega. Now, what you can do is that एक मैं trick आपको बताता हूँ फिर एक छोटी trick बताऊंगा. So first, let me tell you the correct way of solving this, the longer method. Okay, longer method. I told you that the pressure starts to vary if there is any force or pseudo force also acting in any of the directions, right? So here, if you figure out what is the force that will be felt by any element, so consider an element of the liquid here. If this has a small mass dm, right? So this will feel an acceleration in this direction. Will feel a force, centrifugal force from the reference frame of the container. If I go into the reference frame of the container, this guy would feel a pseudo force, right? A pseudo force in that direction. So that will act as a component of gravity, right? So what will be the pseudo force? You realize that the pseudo force df pseudo, that would have been dm omega square times x if this is at a distance x, right? So at a distance x, I can say the value of effective gravity in x direction. Can I say gx is omega square x? So I should have pressure variation in the x due to this, right? So one way of solving this is I can say that dpx, change in pressure when I move in x, would be rho times gx dx. So assuming you are moving by a very small distance, so that you can ignore the variation of this. This is also dependent on x. So if you write this, then if you integrate this, then you have omega square x dx. And if you go from here, let's consider the pressure here as P1 and let's consider the pressure here as P2. So if you go from P1 to P2, okay, so those limits should be applied here. In the x direction, I'm moving from P1 to pressure P2, and in x, I'm moving from 0 to L. So that'll give me the relation between P1 and P2, right? So I'll get P2 minus P1 equals rho of omega square x square by 2 from 0 to L. So rho omega square L square over 2. Now, if I say that this is at some height h2 and this is at some height h1, so can I also say P2 would be rho g h2 and P1 would be rho g h1 plus P naught, of course, on both the sides. If you substitute these values of P1 and P2 over here, what you get is h2 minus h1 times rho g becomes equal to rho omega square L square by 2. So from here, h2 minus h1, which is nothing but your h is coming out to be rho omega square L square over 2g. Okay. So yes, h comes out to be omega square L square over 2. Option D is the correct answer. So that is the long way of seeing this. Now there is a shortcut. There's a shortcut of seeing this. Now, strangely enough, let me tell you one more thing. Let me tell you one very, very interesting thing. Okay, so imagine, let's consider ourselves two situations. In one, you have a vessel, complete vessel, okay, and this has some water. This is being accelerated. And next, you have, instead of this, you have this kind of a vessel. And again, this also has water, just like this. And imagine this is also being accelerated exactly by the same acceleration A. Now, what you will notice is that in both these, the height difference between the ends is exactly the same. Why? Because you realize the pressure variation between the two ends. So when this happens, if this tilts like this by some angle, turns out when here the same thing will happen. It would have tilted by the same angle theta, and that should be obvious. That should be obvious. Why? Imagine the pressure here. The pressure is P1 here. Then the pressure, assume it's P1 here also and it's P2 here. Now you realize these difference in these two pressures would have to be the same, because in the x direction you have the same acceleration, right? So in the x direction you have the same acceleration. So if I take the two bottommost points, then the pressure difference has to be exactly the same. If the pressure difference has to be the same, then you will realize that the height difference also has to be the same, right? Height difference, if this is h, then this will also be h. Now, if the base lengths are also same, if the base is L and L, then you realize the entire angle would have to be the same. Did you guys follow this? First of all, let me know. Did you guys follow this? How many of you followed this? That if I compare these two situations, in both of them, the line joining the ends would have made the same angle theta. Why? Because both are being accelerated by the same acceleration. So the difference, you realize the difference between the pressure at this point and this point would exactly be the same as this point and this point. So because of that, the height difference would have to be the same. This will have to be equal, and hence, if this is also equal, if this length is also equal, then you realize for this tan theta, what will be tan theta? Focus on this triangle. If you focus on this triangle now, the tan theta is h over L. So since the h is same, since the L is same, so the tan theta would be the same, and both of them would make the same angle, correct? Okay, everybody satisfied with that? Now let's talk about the interesting bit. Now you realize when you realize this is being rotated. Now I'm talking about the shortcut. When this is being rotated, right? So who had a problem? Krishna had a problem, right? Rishabh, or is it Rina? Rina had a problem with this. So when you're rotating this, you realize that the acceleration at a distance x is given as omega square x, right? So what is the acceleration here? It is 0. What is the acceleration here? It is omega square L. And it is increasing linearly. So what is the average acceleration? Can I say what the average acceleration is? A average would be omega square L by 2, correct? The acceleration changes from 0 to omega square L. So can I say that the average acceleration would be this? Now all you need to do is, tan theta would now become A average over G. That's it. Okay. Now if the height difference was h and this base was L, then tan theta is also equal to h over L. So this is the shortcut wherein you can find the answer almost in one go. Just find the average acceleration. The average acceleration would be omega square L by 2 for the entire fluid in the x direction. Average of the accelerations would be this. Now, if you equate this, let's see what you're getting. So you'll be getting omega square L by 2 G plus h over L, which gives you in one go h as omega square L square over 2G. कितना मिस कर दिया? Now it's almost over. This is the last question that I had planned for today's discussion. Okay, Shivam, you are very late. So let me know if you followed this. So this is going to be your trick. This is a trick that you can use while calculating your answers. Right? Next time you can use this trick. That tan theta can be also written as A average over G. So find the average acceleration, find the tan theta, and then immediately in one line you can find the value of h. Okay, so does it make sense? Did you guys follow this trick? Did you realize what we did? We equated this to a straight acceleration, and the average value of that straight acceleration can be taken to be as omega square L by 2. Why? Because one end actually had a zero acceleration. You can see here, this end has zero acceleration, this end has omega square L acceleration, and the acceleration is increasing linearly with x, right? It is increasing linearly with x. So what will be the average value? So the average value would be the average of 0 and omega square L. The average acceleration, I can, instead of this rotation where every point has different accelerations, I can imagine that this entire thing was being accelerated like this with an average acceleration of omega square L by 2. That's it. That will help me get the correct answer. Of course, I can either go for the integration bit, or I can use the idea of average acceleration and get my answer with the help of that. Again, no matter what I do, as long as I'm doing it correct, I'm getting the correct answer. Okay, so let me know if you guys followed that. Give me some reaction, people. Does this make sense to you? So quickly go over this one more time. Okay, just try and think about this one more time. Now, this is the trick that we are trying to use. And those of you who don't like tricks, which I really doubt, I think all of you want tricks more than the regular methods, right? So I know a lot of students, they just want tricks. Sir, tricks बता दो, लंबा method क्या करेंगे? So this is the trick that you could have used. This does not require any extra any integration. In one line almost, if you just need to write the average acceleration, then tan theta equals average acceleration over g. That's it. So this would have gotten your answer very quickly. So go over this. Let me know your thoughts. Let me know if there is any confusion, any part of the trick that you do not understand. I hope you followed the logic of this. Okay. And now please remember this. Next time you come across such a problem, Reena Patel, so who was in fact said, I found problem in the rotating container concept. You should be able to find the answer now quickly. See, what is happening is why is the difference in height coming? Okay, so here, yeah. I need this wrong. Height would have increased on the outer side. Here. What is happening is that when you are rotating this, the fluid is getting thrown out due to the centrifugal force. Right? All these fluid molecules are feeling a centrifugal force, because of which you will find that this fluid tends to flow outwards. Right? This fluid feels pushed outwards. That is why, because of this outward push, you are seeing the water level rise here and dip here. Okay. Again, this is the integration method of solving this. You could have said that every molecule is feeling a pseudo force when I go into the reference frame of the container. Again, please remember that this is a part of fluid statics. So to make the fluid static, I always analyze in the reference frame of the container. That is only when I will find the fluid to be static or at rest, right? All the fundamentals that we are talking about are for fluids at rest. This is the way of integration also. You can, if you want to understand this, you go through that also. But then when you have the trick, why bother, right? Anyhow, this is for your conceptual understanding. And for problem solving, I would advise you guys to use this. Okay. So that is it, guys. That is my time for today. We will carry forward this discussion on fluids. I think we will need 2 more sessions at least. Not at least, but maximum. Okay, so we will continue this. This is Sunday. So I host this series every Friday, Saturday, and Sunday. So we will continue this discussion on the next Friday. Okay, so join me and I'll keep telling you some really cool tricks with respect to fluids. And not only will we be discussing all our concepts, we'll be going over all our concepts. I'll also be sharing a lot of very cool tricks with you guys. All right. So again, if you haven't installed the Unacademy app, what are you waiting for? Join the Plus courses. Keep getting such cool tricks and such cool concepts. Okay, as being a part of a regular course there. All right, and this is how you should be installing This is how you go ahead and install and get yourselves the Unacademy subscription. So go to the app, open your app, go to the plus section, select your goal as IIT JEE and click on the get subscription button. Next, when you have clicked there, then you'll be redirected to the payment page. Here will be a box which will say, do you have a code? So yes, you do now. And the code is RD Live. So RD is me, Rohit Dixit. So you're watching my live class. So you can use this code RD Live. This will give you huge discount, which is the maximum discount of 10%. Okay, so there are a lot of codes available in the market. But if you use this code, you will get a discount of 10.00%. So I am offering you an extra 0.00% discount with this code. So don't tell anybody and just keep it to yourself. Use this code, get your subscription. Now you can also choose from these two kind of subscriptions, plus or iconic, right? So you can select any subscription that suits you better and click on proceed to pay, and you can again choose from a lot of no cost EMI options to make your payments. Right. So talking about the iconic subscription a little bit, the iconic subscription is a new offering that Unacademy is giving you. So now, along with your plus subscriptions, which is the regular subscription, which was the only subscription available earlier, now you can also go for a plus iconic subscription. So what is so different about this? This is all the features of the plus plus some extra benefits, right? So what are the extra benefits? This subscription will take your IIT JEE preparation to the next level. How do you take your IIT JEE preparation to the next level? Well, you'll be allotted personal coaches first of all. From the entire pool of professionals, you get allotted personal coaches who will closely mentor you throughout your IIT JEE journey and keep giving you close feedbacks. Okay, so you are getting more individual attention, so to say, with this subscription. Okay. Now, you will also attend IIT JEE workshops on a regular basis. You will keep receiving timely expert guidelines regarding your preparation. You will have a study planner and you have regular test analysis sessions, which will help you boost your preparation. Okay. Next, as I told you, so some people were asking me, sir, how can we get this subscription for free? So how you can do it, by the way. So you can compete in the Unacademy Combat. This is the most competitive, gamified IIT JEE battle now. And the next event is going to be happening on the 20th of December. So you can enroll in that. So not only does it give you a good practice, it gives you a chance of seeing where you stand with respect to your peers. Because trust me, a lot of students enroll in this. So it will be a very, very good way to judge you with respect to your peers. Now, and also if you do well, you stand chance to win some really cool rewards and prizes, which include a lot of Unacademy subscriptions plus a lot of other very cool prizes like laptops. I think I don't exactly know what the prizes were. I think you can win some laptops and something. All right, is it introduction session? Yes, it was. Now we have reached the end of that session, Sai Teja. This was the part one of the discussion of fluids. Okay. Now, when you click on, you can enroll for this Unacademy Combat, the next Unacademy Combat, which happens on 20th of December, using the code RD Live. So if you have been regular in my lectures, and if you use this code RD Live, so it will give you luck and you will do very well in this code. Okay. So if you've just been regular in my lectures, then you will do well. Don't worry about it. All right. So hello. Good evening to you, Bharadwaj. How are you? Now, Unacademy is also hosting a Class 10 boot camp for all the IIT JEE aspirants for 2023. So, all you students in Class 10 who are confused about how to start your preparation, you can join this boot camp, get a taste of how your preparation is going to be. Okay, today only, yes, we started the session on fluids today only. Okay, so you can go over this session later, maybe, and watch the recorded version. Okay, and join from the next live session. Okay. Oh, I am great. I am great. Thank you for asking, Bharadwaj. Okay. So that's it. That brings to the end of our discussion. Again, if you like the video, then don't forget to press the like button. Okay. And I see a lot of you guys press the like button. That's fine. But I don't think you people share it. Why are you being selfish? So make sure that this quality content is available to all. All right. So knowledge should be spread. Okay. Sai Teja, this is the end of the session. This is the end of the session. You are joining us at the end of the session. The session started at 4. If you note your schedule, this session started at 4. We are just ending it now. And don't worry, I'll be ending it very fast now. Okay. So make sure you're also sharing this with as many people as you can so that more and more students can benefit out of this quality content being given provided to you by completely free of cost by Unacademy. Okay. If you're new to the channel, don't forget to subscribe, and trust me, you will keep receiving such awesome, absolutely free content here that it will definitely worth it, and it will definitely help you with your J prep. Don't forget to press the bell icon, and the PDF notes of all the slides used in today's lecture would be available for download very, very soon. Yes, sure, Saiteja, no problem, no problem. Those of you following us on the JEE English channel of YouTube can now connect with us on the Telegram app using this link. Yes, I know. No problem, no problem. That happens. That is why you need to join this channel. That link. Get that link. Join that group so that you're getting timely notifications. And next time this does not happen. Okay. Now next class will be on Friday. Sateja, next class is on Friday. Class on Friday at 4. So if you're looking to revise fluids, that class will happen at this time. Okay. As I keep saying, that is the point of joining this Telegram group. No, you will receive all the timely notifications. You won't have any confusions about the session timings and which days the sessions are happening from now on. Okay, do that. Next, before I leave you guys, let me remind you that this is the code that you want to do. You want to use in case you are planning to prepare for JEE and you're planning to get your Unacademy subscription. This is the code for you. Use this code and you will get selected in IIT JEE Mains and advance or whatever dream exam that you're preparing for. You can enroll in my lectures. I will guide you through all your exams. I will answer all your worries. Okay, and I will be your guide and I'll mentor you personally. This code will also give you an amazing 10% off on all your subscriptions. All right. So again, it gives you a chance of being on the plus, and this is only some flavor of what you will be experiencing there. So trust me, there the amount of content that you'll be getting is many times more than what you get here. Here you are just watching few lectures. There you can have access to a pool of lectures. Okay. So with that, anyways, I'll see you next Friday, where we will carry forward this discussion on fluids. All right. Till then, you guys keep studying hard, keep practicing, and take good care of yourself. Okay. Bye bye.